Hi, everybody. My name is Jesse Wilson, and with me is...
I'm Egor. We're both at Square.
Excellent. So here we're about to talk about a library called Okio, and I like to call it Okio, or maybe Okio, depending if you're from Ohio or not. So Okio is a library that complements java.io, java.nio, and it's just a better API for doing I/O streams. It's a little bit of a better API, and I think it's a little bit more of a better abstraction. So when we're writing a whole bunch of I/O libraries at Square, we use OkIO as our superpower to make those I/O abstractions easier to build. It also has better performance, and it does this by just being very aggressive at automatically batching up and buffering all the reads that it does. And the project, we didn't go out to build an I/O library. Only crazy people go out to build an I/O library. But what happened was we were working on OkHttp, and everything in OkHttp was just hard to do. We want to read a bunch of data from the HTTP headers and decode them, or we want to decode chunked encoding or gzipped encoding. And we just found that we were constantly fighting with the Java I/O libraries. So eventually, we built our own abstraction in OkHttp, and then later, we pulled it out as its own standalone library. It's the basis of many Square open source libraries. So we use it in OkHttp, Moshi, our JSON library, Wire, our protocol buffers library, and it shows up in Retrofit, which is the beautiful abstraction you all have to deal with that puts them all together. So this is sort of like what our Square stack looks like with all these things stacked on top of each other. And we're here to talk about OkIO and its relationship with Kotlin. And Square has been really excited about Kotlin for a very long time. I'd like to say that we were interested in Kotlin, it's kind of like knowing that band before they were famous. We were into Kotlin before Kotlin was cool. So it started, there was an engineer at Square named Jake Wharton, and he wrote this very influential post that eventually caused him to leave Square, called Using Project Kotlin for Android. Project Kotlin. Think about that, Project Kotlin. That's what that Kotlin was originally called. And we've done these blog posts where we're talking about how we want to make Kotlin really easy to use from our open source libraries. Last year, we went through all of our libraries and we added nullable annotations to them just so that they would be really friendly to use in Kotlin. And we're even building new, weirder things in Kotlin. I'm currently working as a server programmer, and we're building a server framework called MISC, and it's 100% Kotlin, and it's a lot of fun as a consequence. So this talk is about taking OkIO, which is the sort of core centerpiece of all of our I/O networking libraries, and taking it in Kotlin and trying to get the two to play well together. And this project has been a lot of work in the making. We've been big fans of Kotlin for a long time, and whenever we want to do how do we make retrofit work really nicely with Kotlin, it often is well, it would be easier if OkHttp did it, and then when we look at OkHttp, it's well, it'd be easier if OkIO does it. And so we feel like this is the very first step for all these libraries. And so we've had lots of different attempts at this project. The first attempt, we have this GitHub repo called KOIO, and we're OkIO is their Java library. Let's just build everything again in Kotlin. And so it was a very fun, ambitious project. It was built let's start with Kotlin from scratch. We started with an empty repo. It was multi-platform from day one. It would support all the different JDKs. We were really ambitious, and it failed. And it failed because it was like a boiling the ocean project where we were trying to support everything all at the same time. And just lots of different things went wrong. It was too ambitious. We were missing primitives. So when you use OkIO, it's doing a lot of sort of core fundamental platform I/O things for you, like decoding character sets, or doing thread hopping and concurrency unlocking. And those things don't exist in Kotlin for JavaScript. They didn't exist at the time for Kotlin native. And so we just tried to do this, and everything we ran into, it was just not ready yet. And so a lot of the reasons that KOIO failed was it was just too early and it was too big. So attempt number 2 is the exact opposite. This is sort of, what's the simplest possible thing that we could do? We would just, take a pull request from some guy with an orange avatar icon that adds a bunch of Kotlin features to OKIO. And so we take the library and we give it the regular KTX treatment. And this is a very pragmatic approach, and so it wasn't for us. It was just add some Kotlin stuff, add some extension functions, make it a little bit nicer. But we just felt like it didn't go far enough. This is sort of like this is like Goldilocks. It was too little. So problems. One big thing is that we had no path to multi-platform with KTX. KTX made it so that Java and Android users got the best Kotlin experience, but we never had the ability to say, how are we going to take this part and eventually get retrofit working on iOS, which is sort of like this end of the rainbow kind of goal. It means that we have redundant APIs for Kotlin callers, so if you're a Kotlin user, you can have the bytestring.decode hex, or you can have string.decode hex. It was just awkward. We didn't like how duplicated it was. And this is close to home. We're big fans of Kotlin, and the KTX thing is great for all our consumers, but we wanted to enjoy that Kotlin, sweet Kotlin ourselves. So attempt number 3 is called OKIO2, and that's what we're here to talk about today.
Right. So our third take on it, which eventually became OKIO2. So it started this year, and Jess actually published a GitHub issue that it serves like a design document for it. So it kind of describes what we really wanted to achieve. But in a nutshell, it's so of course we wanted to be multi-platform. But we knew that we had a really good support for JVM, so we decided, why don't we kind of start multi-platform, but we start targeting only the JVM platform to start with. So we want OKIO2 to be written 100% in Kotlin, so drop all the Java code. And gradually, because we will have it as a multi-platform project, we'll have the opportunity to gradually add support for JS and native. It's not we're not pressed to do it at the moment, but we will have possibility to do it later. Right, so speaking about I/O on JVM, so right now there's 2 main ways you can approach it. So you have the old Java I/O APIs, which are pretty straightforward. They're of course blocking. You have pretty good performance with them, but you hit the ceiling of the maximum number of threads you can use with those APIs. On the flip hand, you have the Java Neo APIs, which still give you pretty good performance. And the advantage of them is that you don't have this thread count cap anymore. But the problem is that the API is callback based, and we all know that this can make the code pretty clumsy. So then we have Kotlin coroutines, where actually they take the best of both worlds in terms that you get the straightforward blocking API, which in fact gives you the same good performance, and actually the same advantage of no cap on the thread count. So this is a pretty cool thing, and we're really excited about being able to use Kotlin coroutines with OKIO going forward. Another thing we really wanted, as Jesse mentioned, is the idiomatic Kotlin API. So we still wanted to keep user experience good for our Java users, but we wanted our Kotlin users to feel like they really use a Kotlin library, but not just like a Java library that is interoperable with Kotlin. So I wanted to use all the features in Kotlin, such as extension functions, which you're accustomed to if you're a Kotlin user, but that still can be used as static methods on Java. So a few examples of that. As I mentioned, on OKIO 1, basically you had a lot of factory methods when you wanted to wrap certain resources in OKIO idioms. So for example, if you take a file and you were going to create a source out of it, which is one of the classes in OKIO, you would use like this sequence of factory methods. Whereas in Kotlin, in OKIO 2, Those are all extension functions, and this is a win on multiple fields. So specifically in discoverability, so when you're working with Okio, it's really easy to find how the APIs work. So you would just like invoke file constructor, tab dot, and the autocomplete in the IDE would just show you what the APIs look like. So it's pretty cool. Another example is, so we had a method called getByte, which takes a position and returns the byte on that position, and it looks almost like an array access, right? So you just like query an element on a certain position. And of course in Kotlin we can use an operator function for that, which will actually give us this bracket syntax. And we can also apply JVM name and attention to it to keep the APIs unchanged for Java users. Because, of course, Java users don't know anything about operator functions, so we kind of accommodate both. And one more, so another method that we have was getSize, and it looks like a property. So in OKAO2, we just refactored it to the property, and like the call side is a little cleaner. And similarly for Java users, because of the way properties are compiled, so they will, like Java users will still have the getter because the property is compiled to like a backing field and a getter and a setter. So that's where we went with. Of course, like all the magic comes with the cost, and in our case, the cost was that we had to depend on Kotlin standard library, which is actually pretty big if you compare it to the size of OKAO. But luckily, if you're doing Android development and you're doing Kotlin, then probably you already have that dependency, so you don't have to pay that cost. Even if you don't, so we just ran a small test to see how well Kotlin standard library shrinks, and it does shrink really well under ProGuard or R8. So in fact, we just use a really, really small subset of Kotlin standard library. So if you just process it with a shrinking tool, then you will have just really a small overhead on top of the library size. So speaking about the journey to OKAO2, it was a nice journey. It was a lot of fun. So we started with Gradle. We used to build OKAO with Maven before, but we decided to switch just because Kotlin's Gradle story is a bit stronger. So we decided that it's the right time to switch because, like, going forward, we will have less trouble with that. We agreed on the following project structure, where we would have a top-level OKAO folder, which will have its own source directory. So that source directory will have the common code, which is shared between the platforms. And at the same level, we'll have platform-specific directories, so JS, JVM, native. Each of them will have their own source folder, which will have platform-specific code. So then we use two plugins. First is, of course, the Kotlin Gradle plugin. Then we use the Kotlin native Gradle plugin. So at the moment, those are two different plugins, but I guess like at some point they will converge. In the platform modules, we use platform-specific plugins. So for each platform, there's a special plugin. And this is the list of all dependencies we use. So there are like a lot of JDK. I'm not quite sure we actually use the like JDK level dependencies, but like in case your library wants to be more fine-grained and support different JDK levels, then there are standard libraries for different JDK versions. So for publishing, we started with using the famous Chris Baines's set of scripts, but we eventually switched to the plugin by VanigTech. So he actually took the work that Chris Baines had and put it into the plugin, and it's a lot better because it's versioned. So if like stuff changes in future, then we can just bump the version and it will work. So big shout out to Nick for this awesome plugin. And at that time, it was kind of a milestone for us. So we had a fully working Kotlin multi-platform project without having a single Kotlin file. So we still had like just Java, but we already could build it as a multi-platform project. And of course, the next step would be to convert our files to Kotlin. We just went about it one by one. We had smaller files, which were pretty straightforward to convert. Which we had bigger ones, which took some time. But anyway, we had a pretty good suite of tests that we relied on. Of course, the tests were in Java, but like running them helped us understand that we're not breaking any behavior, so it's really crucial. There was another milestone, and at that point, we already were 100% Kotlin. But still, we only targeted Java, right? So we only had our code in the JVM platform module. Everything else was just empty. So we gradually started the process we called backfill, in that we wanted to move as much code as we could into the Kotlin module, common module, I'm sorry. So for some files, it's really straightforward. If you have like just a pure Kotlin file, then you can just straightforward move the file into the common module. That's really easy. In some use cases, we were using dependencies in JDK, which had mappings to Kotlin analogs. So for example, we use Java util math, and Kotlin has its own implementation for mathematical functions, so that was an easy switch. And we switched from integer to int, and like similar examples. In some cases, we had to introduce platform-specific helpers. So for example, in Java, we have the array copy method, and there's no such thing in Kotlin. So what we did is we just added an expect function in common, and on the JVM side, it just delegates to Java's array copy. And of course, on JS and native, we just like implemented it on our own because like it's not a hard piece of code. And of course, we had cases where we were actually doing something with specifically Java APIs. So for example, there's no notion of output streams or input streams in Kotlin. So this is the code that has to stay in Java, so we didn't move it into common. At the next step, when we had some of the like expect classes and expect functions, was to implement them in the JS and native modules. So we created actual classes. We implemented the helpers, such as array copy, which I mentioned. And that was another milestone. Again, we were 100% Kotlin. And we had a few proof of concepts for JS and native, which was really important for us to just see that we can build it, we can run tests on all platforms. So it was pretty great. Yeah, and I'll turn Jesse to speak about compatibility.
Yeah, so this library that we built is very, very heavily dependent upon. It's the dependency of retrofit, OkHttp, Moshi and Wire. And these libraries are used in many, many, many Android applications. And so the idea of just taking a very widely used library and changing the implementation programming language out from under you is really, really scary. And we were really afraid that like we would do this and there was going to be some gotcha where we weren't going to be able to keep our library working with Java callers. And so I want to talk about different kinds of compatibility and the consequences of them. So the first type of compatibility I'm going to talk about is binary compatibility. And the sort of the way you think of this, the way that you see this in your development environment is you may have like a Java class, some library at some version. You compile that. The compiler takes both your libraries and your source code in, and it emits a jar file or a dex file or something downstream from that. And this is how we work. But sometimes you'll take a library and a Java class, and you'll run it with a different version than the one that you compiled with. So here we've taken that jar from step 1, and we're using it with a different version of the library. And if you're unlucky and you have a binary incompatibility, what will happen is when you run the program, you're going to see something like a no such method error. And so no such method error is the VM's way of saying the library that you compiled with is not the same as the library that you're running with. And so there's a whole bunch of different errors of this type. There's no such field error. There's incompatible class change exception. There's a bunch of different ways where if the library changes enough in a very subtle implementation-dependent way, things will break. Source compatibility is much more familiar, and we have sort of two kinds of source compatibility that we're worrying about with OKIO. The first is with Java source compatibility. So we've got this function sync that takes a file and returns a sync. And in the Java code that's calling it, okio.sync passes in the file and everything works. This is something we want to be consistent with. But in Kotlin, we actually want to change the way that this function is called. In OKIO 1.x, you do this sort of Java-style static method call. But in 2.x, we want it to be an extension function on the file output stream. And so we changed the way that this API works, and we want to also keep it working in the old way for Java callers. So this is this really weird thing we're doing. We've got one function. We want Kotlin callers to get an extension function. We want Java callers to get what they've always had. And how do we retain this compatibility? And you've seen this. This is one of the tricks that we use. We just use the JVM name annotation on the file, and in the declaration of the file, we have at JVM name. I think that's exactly right. Cool. So I want to talk about. That's perfect. So when you're migrating from OKIO 1.x to 2.x, the binary jar files are interchangeable. So if you have a 1.x Kotlin, if you have a 1.x Java source language OKIO library, and you throw it away and you replace it with the 2.x, if you run it against compiled code, everything will just work. If you compile it against Java code, that's the same. Everything will just work. But if you're going from 1.x to 2.x in a Kotlin repo, a whole bunch of APIs have been moved. We said this thing's going to be an extension function, whereas it used to be a static method. And we are leaning really hard on IntelliJ to help us here. And so IntelliJ has this @deprecated replace with feature. Has everybody used it? It's super duper cool. So we, in addition to moving all of our APIs to their new locations, we also added forwarding pointers where they used to be, all with deprecated annotations, all with deprecation level error. So when you try to compile your program, once you've upgraded, anytime Kotlin code is changed, you're going to get a red squiggly line. This one says, decode base64 has moved to an extension function. And IntelliJ is just incredibly powerful and wonderful, and I love it because you can just alt-enter on this thing and say, fix this usage and all other usages in my entire project. I don't have to read the documentation. I don't have to, do any research or Google this error. I just alt-enter on it, do a replacement, and it will do a fix right then and there, and your fix applies immediately. And so this strategy worked really well for us, and it is sort of emboldened us to get more aggressive about converting Java implementation code to Kotlin and changing the way that APIs work in Kotlin, because I think it's just so effortless to make it so that Kotlin users get this nice idiomatic approach. So OKIO 2 is binary compatible with 1.x. It's source compatible with 1.x for Java users. It's source incompatible with 1.x for Kotlin users because we've moved a whole bunch of things to take advantage of Kotlin idioms. But we've got this better Kotlin-friendly API, and the IntelliJ will really help you do the migration. How do we, maintaining source compatibility was a little bit, we had a lot of help with that because if we accidentally broke it in the transition, a lot of our Java language tests would change. Binary compatibility is way more subtle. If you change the return type of a function, for example, that breaks binary compatibility. And so we leaned really heavily on this tool called JAPI CMP. And what it does is it inspects two jar files and confirms that one is binary compatible with the other. And it was very useful in detecting regressions that we would have otherwise introduced. All right, so we make some changes, we run the substring method, and we've forgotten to add the @JVM overloads. We run the compiler, and the compiler will throw and say, hey, yo, you made a binary incompatible change. Don't do that. In the migration, there were a bunch of different places where there were things that could just break in ways that we wouldn't expect. Internal classes are public in bytecode. So the Kotlin has its notion of visibility, And something can be visible to many packages, but not visible to consumers, and that's the internal visibility. And this is complicated because when we're working on trying to keep everything the same from Java and also use Kotlin, this is an opportunity to hurt us. Everything in Kotlin is final by default. We had a few cases where Java code was implicitly final but not marked so, and it caused us some trouble.
Yeah, so speaking about testing, I mentioned that we relied on tests quite a lot while we were migrating. So we decided that we will not be explicitly rewriting our tests in Kotlin, just because it's really valuable for us to have them, because they test our APIs from the Java user's perspective. So even though maybe they will duplicate some of the future tests we'll have in Kotlin, we still want to have some code that uses Okio using the Java APIs. We added some Kotlin tests on top, and even though there are some examples which do the same thing, but again, so these tests test the Kotlin side of the API. And eventually we were moving some of the Kotlin tests to common, and the advantage of that is that when you run them, they run on all platforms, so you can test 3 platforms at the same time. So bytestring is an example of it's a pretty large class that we made fully multi-platform with the common expect class and the implementations in platform-specific modules. So here's how it looks in the common directory. So this is an expect class with a bunch of stubs for properties and methods. And we've got an actual class in JVM. The reason we went this way because we wanted to add a super interface. In this case, this is serializable. That only exists on Java side. And also, this actual class has a bunch of Java-specific things, such as this write method. So we hit quite a few roadblocks on the way there, specifically in a few Kotlin multi-platform issues that we reported and that were already reported. So one of the big ones for us was the inability to have default implementations in expect declarations. So like in this example with bytestring, we really struggled with having just pure Kotlin code in common, just because we had expect class. And we kind of found that this is a pretty popular concern. This issue has a few upvotes. So we look forward to this being addressed. Another thing, so we found a few use cases where we really wanted to use platform-specific annotations in our common module, which kind of sounds counterintuitive, but in some use cases it really was a way to go for us. And the Kotlin team actually introduced a new annotation called optional expectation. So the way this works is if you have an annotation in common module and you mark it with optional expectation, then you don't necessarily have to have an actual version of it in the platform modules. So you can omit it for certain platforms. So this already exists, but all of the standard annotations such as JVM name, JVM overloads haven't been marked with this annotation yet, but it's coming in, I think, 1.2.70, so then we'll use that. Another issue we faced was, so in one case we wanted to use a class delegation, but we basically noticed that so the checked exceptions are not retained in bytecode in that scenario, so it was crashing for us, so we reported that. Another one, so we had an expect function with a default parameter, and we marked it as JVM overloads, and it was not compiling properly. And this issue was actually fixed, just to showcase that there's a lot of work happening on Kotlin multi-platform, so it changes from every version. And yeah, there's a lot of stuff being fixed. Last but not least, so Doka, the documentation engine for Kotlin, doesn't support multi-platform at this time. So we kind of have to duplicate our documentation. So naturally, we want to keep it in common, but right now we just have to copy this stuff. So have documentation in JVM module as well, and we really want this to be fixed. So yeah.
All right, so this is all for naught if this very widely used library is slower in Kotlin. And this is something where we knew that we could inspect the bytecodes and see what the Kotlin code was doing and the Java code was doing, and we could convince ourselves that there was no regression, but we were really worried that we were going to spend all this energy converting this library to Kotlin, and then it would be slower, and it was. When we did some benchmarking, we've got a whole bunch of different benchmarks that we use. This one is benchmarking how fast JSON reading is on top of the OkIO library. So we are running Moshi, we're doing a bunch of JSON decoding, and on the left is the throughput, how many basically megabytes per second we can do with OkIO 1.x, and then we swap in the IO library underneath, and it's slower, and this is a little bit disheartening. It turns out that we made a really easy mistake, and it was an easy fix. In Kotlin, if you have double equals, that calls the equals function, and in the very inner loops of the very bottom of our IO library, the difference between a equals call and a reference equality, which is triple equals, is enough to break your benchmarks. And so we fixed this bug, we went back and reran our benchmarks, and it turns out that afterwards Kotlin was a little bit faster. We're not sure where that additional speed comes in. I think that's mostly measurement error. But we were really aggressive at trying to find places where the Kotlin one could be worse. And we found and fixed one. So what's the result of all of this energy that we've been spending? Well, today I'm very, very happy to announce that we're releasing OkIO version 2, which is implemented in Kotlin. So that's today. We've got a blog post on our Square Engineering blog that basically is the Coles notes of this talk. We're going to just talk a lot. The blog post talks a lot about what the consequences are for Java callers because we're really worried about making sure that this brings them along. And we've got some future plans. So we want to keep backfilling things into common. We have a perfectly working library for Android users, but we're not going to stop there. We want to make, eventually, our networking code work across multiple platforms. We want to do coroutine support, and we want to do this for the server so we can write regular, boring code like Moshi and Wire to do our parsing, and then we want to run it massively parallel on our backend. We want to do Kotlin native, and we want to start working on our IO libraries. So someday, OkHttp, this will be way bigger. OkHttp is about 10 times bigger than OkIO, and it's a bigger effort, and there are even more places where we can harm ourselves. Retrofit, same thing. Someday we'd like to migrate it to Kotlin. Moshi is actually sort of ready for this because we've already done a lot of work in the Moshi library to support Kotlin as the objects that we're converting, but Moshi itself is implemented in Java. And Wire is very, very ready to be converted to Kotlin. We're on the verge of having some code where you can take protocol buffers in and emit Kotlin as the source code, and you get like nice Kotlin data classes. A lot of this talk is not about OkIO, but the recommendations for anybody else who maintains a Java library, possible open source or possibly something that you're using in your companies. And we want to help you to migrate your library to Kotlin as well. And so we found that although we had two attempts that failed, this third approach worked, and we have some advice. Start with a JVM target, rely on your JVM unit tests, use this Java API CMP, and backfill. So just once you have everything working, that part is relatively mechanical, and then you just migrate slowly Java code into Kotlin. And if you run into Kotlin multi-platform issues, report them. JetBrains is incredibly responsive, and it's just really satisfying to work on a platform where you say, hey, this thing is broken, and they say, oh, just check, in 1.2.50, it'll be fixed for you. So it's a really great language. It's really exciting to be moving on a platform that's moving so fast, and that's just solving more and more problems every day. So thank you very much.